right, so as we're going to geometry, this is your geometry preview, okay? So
Can we get the document in the chat to print it?
if you guys want to print it, let's do that. That's a great idea. That's Kelvin. That's usually what Kelvin does, and I totally forgot about it.
I got you, Dylan. I'll drop it in the chat.
But yeah, give him the blank copy. Awesome, awesome. Amanda, thank you for keeping keeping me on track. No, what's the phrase? Keep me in check. There you go. That's the saying. All right, thank you for keeping me in check. Okay, my phone's on mute. We're ready to go. So actually, Amanda, since you have muted, I know you don't have the document printed, but you can still read the question for me, right?
We can. Okay, how many lines of symmetry do the following figures have from left to right?
Okay, awesome. So line of symmetry. What is a line of symmetry? So a line of symmetry. All right, this is going to be like
the line that goes down between two sides that are the same.
Spot on. Absolutely. All right. Imagine that line being a mirror, right? So if we have a mirror right here, we have one shape over here, and then we have the exact same shape. We have the exact same shape on the other side. I know this isn't, okay, that's especially not the exact same shape, but just pretend. Imagine that I made the exact same shape on both sides. That line of symmetry is going to be that part in the middle, okay? So this shape right here has one line of symmetry, okay? But shapes can have multiple. So how many lines of symmetry does the left figure have? How many times can you cut it in half? And it's totally, completely equal on both sides. One, right? So we can cut it this way, down to 2 points. And we just made two triangles that each look exactly the same. This is triangle 1, triangle 2, okay? So this one has one line of symmetry. So some of you may think, oh, we might be able to cut it this way, but those halves aren't equal. You might want to cut it this way, but these halves aren't equal, okay? So although this line might look like it fits, the two sides have to be exactly the same. So this shape has one line of symmetry. So that eliminates those two answer choices. What about this shape? What are you guys thinking? And this isn't just Amanda. You guys can unmute and respond.
If you cut it down, if they're all the same length and you cut it down by any of the points straight, it'll work.
Exactly, right on the money, right? So
explain that correctly, but
I totally get where you're gonna go at, and you're actually going a step above what I was planning on going over for this question. But yeah, when all the sides are the same, right? All these sides are the same length, and all these angles are the same, right? Then that means that there's going to be the same amount of lines of symmetry as there are sides. But that's a little too complicated. But Amanda killed it. Exactly. Okay, so just to draw those in, we're going from a point to a side. Notice how this half is the same as this half, right? And then point to a side. So this half is the same as this half, right? And then we just keep on doing that for every point, and we end up with a total of 5. Ooh. Okay, it's not going to auto straighten. There you go. And so there are 1, 2, 3, 4, 5 different lines. There are 5 lines of symmetry on this question. So what's the answer, guys? Not just 5.
B.
Perfect. All right. Look at that. You guys haven't even taken geometry. You're already nailing these questions. All right. That's a good sign. Let's keep on going. So what is the order of rotational symmetry for the figure below? So before we were talking about lines of symmetry, right? So what we were doing is that we would get this shape, and then we would flip it. We'd put it on this side, make it go to that side. We would flip it. That's the line of symmetry. That's one type of symmetry. There's another type of symmetry that has to do with rotation, okay? So imagine that this is a really poorly made wheel, okay? And we have a center right here. We have an axle here, okay? We can spin this thing around the axle, okay? So imagine that we have that center, there's an axle, you can spin it, okay? So, well, I'm gonna do something really big brain. You guys ready? Okay, look, I'm gonna name this 1, 2, 3, 4, 5, 6, 7. Hopefully this works. Copy. Paste. No. Paste image. There you go. Okay, look, we have a duplicate. All right, you ready for this? Boom. I just rotated it around that axis. And look, it maps up. Well, not perfectly because I'm bad at this, but it more or less lines up with what the original shape was. Okay. And then we can do one more time. Boom. And now we're here. Again, doesn't line up perfectly, but you get the gist. So you can keep on going. Again, there's one more and one more and one more. One more until you get back to the original. Okay. So the order of rotational symmetry is how many times, how many different positions can you be in that the shape looks the same before you get back to this original state where you have the 1s and the 2s. Guys, how many times can you rotate that? How many different positions are there that they look the same?
6.
So let's check that, right? So we have, let me pull this up.
Are we thinking of it as poorly made? Or are we thinking of it
No.
as
We're assuming that all the sides are the same. Okay. So
Okay.
even though the shape isn't perfect, like just pretend, let's imagine. Okay. So in this case, what you said before, because all the sides and angles are the same, there are 5 lines of symmetry. The exact same thing applies here. There are 7 sides. So what is the order of rotational symmetry?
I thought there were only 6. I would have answered 7.
Oh,
I was thinking the same way. I just only saw up to 6.
yeah.
I read the
yeah.
7 as a 1. Okay.
I don't know.
Sorry.
It could just be my terrible handwriting. Who knows? So guys, does that make sense? There are 7 sides, so we can rest on each side every time we move. Put a R for rest, if that makes sense. All right, that we can rest on each side. Put an R for rest, if that makes sense in the chat. All right, if that makes sense, put an R. Okay, awesome, cool. So that's rotational symmetry. All right, that's our second concept. We're flying. All right, we're going at a blinding pace. Okay, on to the next one. Okay, and this one's also going to have to do with shapes that have the same length, side lengths. Okay, so what is the measure? Actually, I guess I'm going to read. I've been reading a lot. I've been talking too much. You guys are going to tune me out. Mia Fortugno. Did I butcher that?
Yeah, no, it's fine. Fortuno.
Fortuno. Oh, you don't pronounce a G. My bad.
What is the measure of each of the interior angles of the regular polygon below?
Ooh, okay. Here's some vocabulary. Regular polygon. Okay, let's break that up. First off, polygon. What is a polygon? A polygon is literally a shape. A shape that has sides. Okay, that's a polygon. Nothing too fancy. All right, anything that has, it's a shape with sides. Please work. Okay, it's supposed to make it all pretty, but this, although we don't know what the name of this is just some random shape. It has sides, right, and it connects. This is a polygon. Okay, now this is a very irregular shape. It's not normal. So what would a regular polygon be? What do you guys think? What is a very regular shape? Very well-known shape. This is not a trick question.
A square.
A square. That is exactly what I was thinking. Okay, a square. It is a very regular shape. It is so regular, in fact. Oh my God, why isn't it like, it's supposed to auto-correct my shapes? There you go. Ooh, that's not a perfect square. It's like more of a rectangle, whatever. So it's a square, right? And what makes it so regular? Well, all of the sides are the exact same length. And since all the sides are the same, all of the angles are the exact same measure. Okay?
So in order for it to be regular, all the sides need to be the same.
All the sides and all the angles need to be the same.
Okay.
All right, so that's a regular shape. Okay, regular polygon is any shape with all the sides and angles are the exact same. Okay, if you guys taking notes, that's a good thing to write down. Regular polygon, shape with all the same sides and angles. Okay, now
Right and angles.
all
you
all the same sides and angles. So this one just so happens to have right angles. That's not the case for all shapes. Is that what you asked?
No, you put a shape with the same sides when you wrote it. I put right with angles, with the same angles.
Oh, yeah. So yeah, just a polygon in general is a shape with sides. So a regular polygon, yeah, I should write it down. So it's going to be a
When I said
polygon.
right, you comprehended it as a right angle.
Yeah, that's what I yeah, but I need to write it down anyways. So with same sides and angles. Okay, cool. Regular polygon. We got that out of the way. I saw Ellie laugh. My handwriting is bad. I know. It's like my job is literally writing on this board, right? Like writing on this. That is like my livelihood, and I'm terrible at it.
The part that really got to me is that you put a dash for like the first item on your list, or a bullet for the first item on your list and a dash for the second. And I swear I got like, it was like, I don't know what it was, but it was a terrible, terrible feeling.
All right, that's enough attacking. So I'm gonna give you guys an equation, okay? So the equation that we have is going to be for the interior angles of a polygon. What is that? Well, we're about to go over it. So the equation is 180 times n minus 2, where n is a number of sides. Okay, so what this gives you is that if you plug in the number of sides you have, you're going to have the total amount of degrees in a polygon. No matter what the polygon looks like, use this equation, you'll find the total amount of degrees inside. Okay, so looking at this shape, looking at a square, we have 4 right angles. That means each one is 90 degrees, okay? So what is the total amount of degrees in a square?
360.
360. Awesome. So it's 360 degrees in a square. Let's prove it, okay? We can plug in 4. So let me change the color. I'm gonna go red for the square. 180 times 4 minus 2, which is 180 times 2, which is what? What is 180 times 2? In the chat. I want everyone to respond. What is 180 times 2? Look at that. Either you guys are really quick with your calculators or the mental math is on point. So 360. Perfect. Okay, so we have 360 degrees, and look, that's the exact same answer we got. Look at that. The equation I gave you guys works. Good thing. Okay, now we are here. So that gives us our total, right? But we don't want the total. We want the measure of each angle. Now that's where the regular polygon comes into play. Okay, guys, regular polygon has the same what? What makes a regular polygon?
Same sides and angles.
Same size and angles. Okay, just to reword it, all the angles are the exact same. Okay, all the angles are going to be the exact same measure. They're all going to be the same, just as wide as the other one. Okay, so all of the angles are 90 degrees in the square. Okay, and also, fun fact, there are the same amount of angles as there are sides. So that's angle, side, angle, side, angle, side, angle, side. Okay, so if we want to find out what's the measure of each individual angle, we're going to have to divide. And what are we dividing by? If you want to get the measure of each individual angle.
4.
We are dividing by 4 exactly for a square. But in general, what are we dividing by? In terms of the equation. So we have, so 360 are total. That is what we're what we're dividing if we have a square, okay? We have the same amount of sides as we do angles. What's our variable for sides? what is the variable we have for sides? Sophia, awesome. Mac, Michael, killing it. N. That's going to give you the measure of each angle. Okay, that was long-winded, but I wanted to show you guys why this equation works, and it works for any shape. Okay, this top part works for any polygon, polynomial. No, polygon. Yeah, for any polygon. Okay, this part with the minus n is regular polygon only. Okay, for the divided by n. So that took a minute, but now let's look at the actual question. We defined all our terms. Now let's tackle it. Okay, how do we find the measure of the measure of each of the interior angles of this shape? Okay, how many sides are there? Michael, flying, awesome, awesome, guys. There are 6 sides. 1, 2, 3, 4, 5, 6. Okay, so what are we doing, Michael? What are you doing to 6?
Open parentheses n minus 2. So we're going to multiply 180 by 4, get 720, and then divide that by 6.
Beautiful. Nailed it. All right, this is going to be 180 times 4 over 6. Guys, this is where your calculator comes in handy. What does that equal to? Guys, I need you guys to use a calculator because I don't have mine. I'm trusting you guys on these numbers. We have 120 in the chat. Is that the consensus? Does everyone agree with that? Are these your representatives? Are these the people speaking for the group? Is their answer the unanimous answer of this group? Mac, yes, 120 is the answer. Perfect, okay? So just to review, the total interior angles is going to be 180 times n minus 2, where n is the number of sides, okay? But if we have, and that works for any polygon. However, if you want to find the measure of each angle in a regular polygon, and a regular polygon has the same size, same angles, you can divide that by n. All good? This is your cue to give me a thumbs up so that to indicate that if the thumbs up, it means that you're good. We're good. Cool. All right. Awesome. Let's go.
I think maybe like 3 students took mercy on you with that one.
Yeah. Come on, guys. I'm trying to be personable. I say I give thumbs up. You guys thumbs up. It's a simple process. All right. I tell you guys to give me one in the chat. I tell you guys to give me a 1 in the chat. You guys give me a 1 in the chat. Look at that, right? It's a great system we've got going. It's going to work great. And let's tackle this next question. Okay. All right. Now, what is the value of A in the diagram below? We have a shape. Shapes have angles. Okay. I know. Incredible. So first off, let's tackle this line. Okay. The total that Mac is shocked. So the total measure of a line, right? The total measure of a line. So the angle that a line makes, that's going to be 180 degrees. Okay. So in case that's a little confusing, this is what 90 degrees looks like. All right. This is what like 120 degrees looks like. This is what 170 degrees looks like. And 180 degrees is just a straight line. Okay, so lines are actually just really straight angles. So lines have an angle measure of 180 degrees. Cool. So if the Elizabeth, oh no. So if this whole thing is 180 degrees, and this part of it is 140, what's left? What does that have to be? Mac, killing it. This last one is 40 degrees. Wait. There you go. 40 degrees. Perfect. Okay. We have an angle. Now we're going, oh, look at that. Same situation. If this whole thing is 180, this one's 70, what's this one got to be? Michael, man, outpacing Mac. Nice. Guys, when one person gets the answer on the chat, even though it's already there, I want everyone to I want everyone to give me that answer, okay? I want everyone participating. So this one is going to be 110 degrees. Cool. We have our angles. We can get rid of all this extra stuff. Cool. All right, to keep on going. Now, we have this weird expression that stands for some sort of degrees, all right? Some sort of angle, all right? And we want to know, what is A equal to? Okay, so we got to solve for A. How do we do that? Well, we have a shape, all right? This right here is a shape. What is this shape called?
Triangle.
It has 3 angles. It's a triangle. It's beautiful. It works that way, okay? And if we have a triangle using our equation, right? 180 times n minus 2. What is the total interior angle? Samuel, ooh, a third contender. Nice. That our answer, the total interior angle of this triangle, of any triangle, is 180 degrees. Okay, now let's make an equation. We have 180, right? And that's going to be equal to what? That's going to be equal to angle 1 plus angle 2 plus angle 3. All right, we add up all the angles, it gives us a total. Makes sense. So instead of writing these abstract, just angle 1, angle 2, angle 3, we can just put Mac. Oh my God, you are ahead of me. Slow down. Okay, so we have 110. That's one of our angles. We have 40 for another angle. And our last angle is 3a plus 3. Now, this is an expression we can solve for. Let's solve for a. Okay, so subtract 110, subtract 110. This is going to give us 70. That's going to be equal to 40 plus 3a plus 3. So subtract 40, subtract 40. We have 30 is equal to 3a plus 3. Subtract 3, subtract 3. We're going to have 27 is equal to 3a. Divide by 3. And a is equal to what, guys? What's a equal to? Brady, killing it. Lucas, Michael. Ladies, Valerie, Michael again. Nice. All right. Awesome. Awesome. So a is equal to 9. Okay. So that's our answer. A is equal to 9. Boom. Perfect. You guys are killing it today. All right. So main thing. Okay. This equation, we didn't even mention it and it came up again. This is a really important equation to know. So have this written down. Okay. Also, while I'm here, in case any of you guys are just like, what is going on? Amanda, give me 1 second. So if any of you guys are like, okay, what is going on? This is like, I have no idea what's going on. This is like crazy abstract. How am I supposed to know any of this? Okay. This is previewing information that you're going to be taught by an actual, like, I'm not going to say an actual teacher because I am an actual teacher, but like a regular teacher in like a regular class setting, not on like, hopefully not through Zoom. So like you have a whole year to get all this stuff down. If you don't know it already, that's kind of the point. You're not supposed to know this stuff. Okay. So the point is we want to get you guys a little more comfortable so that when you start off, you're not intimidated by all this new stuff. You can start off absolutely killing it. Okay. So that's the goal. All right. If you don't get everything 100%, that's okay. All right. If you have any questions, you have my email. You'll have Ellie's. You'll get a recap with the document and annotations. You can be good. All right. So let's keep on going. Amanda, actually, what was up?
What do we write that equation is for? Like this is the equation for
This guy?
so that I can write it down.
So this is our total interior angles, right? So
Okay.
total by adding up all the angles, and interior, it's the angles that are on the inside as opposed to the outside.
Okay.
Cool. Okay. So let's keep on going. Okay. Now, this is a shape that you're gonna see all the time. Oh, Got Jezebel in the waiting room. Cool. So this right here, this shape, this little relationship, we're going to see this all the time. Okay. This is going to be a super common, super frequent occurrence. Okay. So we have two lines. Okay. Notice that the lines have this little arrow looking thing. The arrow means that they are parallel. Okay. So parallel lines, they are lines that if you keep on going forever, they will never cross. Okay. They just keep on going straight. All right. So I don't know what to blow you guys' mind. They're parallel. So if you just grab one, pull it up to the other, isn't that just the exact same line? Just shift it up a little bit. All right. Put S for same, if that makes sense. That these lines are parallel, so they're essentially the same line. They're just in a different position. Put an S in the chat, that makes sense. Okay, cool. All right. Now we have an angle, a line cutting through them. Okay. So line cuts through. We're going to have one angle here, and we're going to have another angle here. Okay. Nothing revolutionary. The line cutting through, it's going to make two angles. Okay. What's crazy though is that this relationship right here, it's cutting through this specific line. Samuel, killing it. But give me a second. So these two, this relationship, this intersection, these angles, so this angles happens because this line is cutting through this specific line. Okay. So this is the exact same line. So we are going to get the exact same angles formed. Okay. So since they're the same line, the same angles we're going to get, green is equal to green. It's going to be the same angle. Blue is equal to blue, same exact angle. Okay. And now another thing. You guys ready for this? I'm going to get this. I'm going to grab it, turn it upside down, put it over there. You see how perfectly that lines up? You see how this, what used to be here is now there? And it looks exactly the same. It fits perfectly. That means these opposite angles are all the same. Okay? So this, whenever you see two parallel lines, right? You have two parallel lines and you have one line cutting through it, you're going to have 8 different angles, but only 2 different angle measures. Okay, so 8 different angles are formed, but there's only 2 angles. Okay, you're only going to have blue and green. Those are the only 2 angles you're going to have. All right, so that's this figure right here. So green is equal to green. What can we do from that? What equation can we make from that if green is equal to green? Now we're looking at the actual question. Now we're looking at the variables and the expressions they give us. What can we write? You can unmute if you like. Whoever the person who wants to answer is. If green is equal to green, what can we do? Michael, absolutely, 100%, right? These are equal, okay? Green is equal to green. So whatever green is equal to itself. This is green, so we have it here. This is also green. It's the exact same thing, so it's equal to itself. It's equal to the other guy. Solve for y, okay? Now, this is a significantly more familiar setting. This is algebra stuff. You guys know algebra. This is already down, okay? So we just got to solve for y. So I want y on this side. I want to keep that sign positive. So we're going to add 32, and then we're going to subtract 9y, subtract 9y, and we're going to get 3y is equal to 36 divided by 3, y is 12. And Michael got there before I did. Look at that. And guys, how's that? Ooh, I took my line. Put that back. There you go. All right. This is a transversal angle. This line that cuts through is called a transversal. Transversal. Okay. Now put a T in the chat if what I just showed you guys made sense with like all the angles are equal. There's only two measures, all that, and then we can make the equation because they're equal to each other. Okay. I did forget a V. Transversal. Man, Amanda, you're supposed to be keeping me in check. I misspelled transversal. Okay, awesome. Let's keep on going. Okay, let's get someone to read because I've been talking a lot. Sofia Scarcejo. Scarcejo. I feel like I've already asked you how to pronounce your last name and I may have forgotten. Your mic does not work. You're good to go. No worries. Sofia Brusos. Can you unmute?
Yes.
Yes. Okay. Can you read this for me?
List the side lengths from shortest to longest for the diagram below.
Ooh, okay. Awesome. Now, first off, we have angles. Okay. What's the total interior angle of a triangle? You don't need to do
180.
180. Just like that, right off the bat. All right. 180. That's your total. Okay. So, and so that like 180 for a triangle, 360 for a square, that's stuff that you should just know back of your head. The equation's good, but the equations really should only be used when you have something with like 5 sides or more. Okay. So
Oh,
commit
we're
that.
gonna. Okay, no, I was just gonna say what to do.
Oh, yeah, no, you can go in. Actually, I want Sophia to walk us through this.
Right.
Yeah. So, yeah, just know that 180 for a triangle, 360 for a square, or anything with 4 sides. Commit that to memory. Okay. It's gonna be you're gonna see those shapes all the time, and the equation is gonna come in handy when you have something with like 5, 6, 8, 10, 37 sides. Okay. So, Sophia, what are you doing now? We have our total. What can we do with it?
So subtract the two numbers from 180.
Exactly. Minus 64, minus 73. We can find, and what does that give us? What do we find by doing that? I'm not asking for the number. I'm just asking like what in general, what does it represent? Map the angle of A. Okay. If we subtract the angle for C and the angle for B, right, from the total, we're going to get whatever's left over, which is going to be the angle of A. Specifically, what's the degree measure? What are we going to get? Guys, the chat is low-key lagging. All right. And I'm blaming that on my computer because I know you guys. And I know you guys wouldn't be stalling to respond to a chat, especially when the answer's already there. Okay. So that's on me. My computer's slacking. Okay. There you go. Now they're coming in. That's better. Cool. Cool. Awesome. So our angle for A, right? A is equal to 43. Cool. That's our first angle. Okay. Now let's go on to some crazy stuff. Okay. So if we have an angle, if we make a triangle that has an angle of like, I don't know, something ridiculous, like 2 degrees, something like that, right? Let's just say that right there, that is 2 degrees, very, very small angle. And we made a triangle with that. Look how tiny that side is. Let's go. Small lettering. Small. Very small side, okay? If we have a small angle, we have a small side, okay? So if we instead had a big angle, like, I don't know, 130, I'm gonna draw it down here, or 145, right? We made a triangle with that. Look how absolutely massive that side is. Not small. It's pretty big, all right? Because this angle of 145 is pretty big compared to the
Missing an L.
2. No, that time was intentional, but thank you.
Oh,
All right. Yeah.
I'm doing it for all of them now that you told me to.
Okay, awesome. Small. No, but I did an O instead of but that looks like an A. It was supposed to be an O. Oh. Okay, that was intentional. Okay. Now, so if we have a big angle, we have a big side. We have a small angle, we have a small side. Okay. So what sides? Let's order our list from shortest to longest. What is the shortest side? Well, that's kind of like asking, what is the smallest angle? What is the smallest angle, guys?
A.
Angle A. Perfect, right? So angle A, 43 degrees, is our smallest side. So what's our smallest angle? So our smallest side is going to be A. All right, very small. Now, A is going to be smaller than what? What is the middle size? What is the middle angle? What's the medium angle? Angle C. Let me move that out of the way. Angle C, that's the middle angle, right? So C, the corresponding side, is that middle side, and the remaining side is going to be for angle B. For 73 degrees, it's going to be the largest angle. So side B is largest side. Okay? All good? And again, just a quick reminder, I am giving a thumbs up. So that's asking that if you are good, you also give me a thumbs up. Cool. Nice. Ooh, Ellie, thanks. Okay, cool. Oh, and I got thumbs up in the reactions too. Awesome, awesome. Cool. Let's keep on going. This one's question 7. Oh, let me get this not small triangle out of here. Stay in your own question. All right. Now, which of the following statements is not supported by the diagram below? All right, it's asking which one is false. Okay, now on to some more like identifying stuff in like nomenclature and all that. So we talked about regular polygon. That's a polygon with what? What's a regular polygon? And everyone should respond because everyone has it in their notes, right? What was that?
Same sides and angles.
Same sides and same angles. Perfect. All right. So that's a regular polygon, same sides and same angles. Has nothing to do with this question, but I just want to make sure you guys, I was just quizzing you. Make sure you guys understood, had that down. Okay. So we have M, this triangle looking guy, and then a 2. Okay. Elizabeth Lucas killing it in the chat. So what this is saying is, what is the measure of angle, right? It's an angle of angle 2. Okay, so the measure of angle 2, what is it? Well, let's see. Angle 2 is this. Okay, is that equal to 90 degrees minus the measure of angle B? Well, let's make angle B. Angle B is this guy. Okay. Okay, so we need to see whether or not this is true. Okay, if it's false, then that's our answer. We're looking for the false statement. Okay, now what is the total degree measure of a triangle?
180.
180. Commit that to memory. All right, no need for an equation. Triangle, 180. All right, boom. So the total is 180. Oh, it's still really, I always forget to like change the thickness of my pencil. It's never the right, like, I always have to change it because I always change, like I zoom out, I zoom in, and I always forget. Okay, so 180. Okay, 180 is going to be equal to all the angles, right? So this triangle right here, this triangle has a right angle. Okay, you can tell because this is a little box looking thing. That means right angle. Okay, and a right angle has how many degrees in it? 90. Perfect. So it's going to be 90 degrees, right? Plus whatever angle 2 is and whatever angle B is. Okay, that's going to be confusing. The measure of angle 2 is And yeah, let me just keep it consistent. Why not? Put that there, put that there. And then the measure of angle B. Cool. All right, now let's try to see if this is true. Solve for the measure of angle 2 and tell me, is this statement true or false? It is absolutely true. Okay, let's prove it. Subtract 90, subtract 90. We're going to left with 90 is equal to the measure of angle 2 plus the measure of angle B. Solve for the measure of angle 2, and then we can just subtract. And we're going to have 90 minus the measure of angle B. Well, that's the measure of angle 2, and isn't that what we had here? Okay, so it's for sure not A. Let's check B. All right, is the measure of angle 3 equal to the measure of angle 4? Well, here's measure 3, here's angle 3, and here's angle 4. Is that true? That's for sure true, because they are both right angles. All right, so it's not going to be B. The angle of CB, no, not angle. We lied. I lied. You guys didn't lie, just me. CB. Okay. Well, let's find C. C is over here. Let's find B. B is over here. Let me use a different color. C is here. B is here. Okay. Notice that I just drew a line between those 2 points. CB means the distance between C and B. Okay, so it's however long this line is. So that's what they mean by CB. Okay, they're just referring to that line made between the point C and point B. Okay, Elizabeth, jumping the gun. All right, gotta let me get to it. We're gonna get to that crescendo. We're gonna get there. All right. So is CB, this line, greater than CD, which is this line? Elizabeth, you're good. You're good. No worries. Elizabeth's playing the game. Yeah. So is this statement true? Is CB greater than CD? Is the green line greater than the red line? Sophia, killing it as always. All right, this is absolutely false. So the last answer choice D. No, this is true. So this is not the right answer. Got tripped up. So this one, the only remaining option has to be the answer, but let's check it. The measure of angle 1 is equal to the measure of angle 2. This is angle 1. This is angle 2. Do they even look the same? Michael, I don't know if you were responding to my question, but you said yeah. No, okay. No, they don't. Okay, cool. I was like, Michael, man, caught Michael slipping. But no, we're good. We're good. Yeah, these are totally different angles. So D is not correct. Okay. And I know it took a minute. It took a while. However, that's just because I'm going through all the foundations for all these questions, making sure that everyone is on board, right? As long as everyone is on board before we keep on going. So we may be going a little too slow for your pace. It's totally fine. All right. Once you're in your actual geometry class, you guys can absolutely kill it. And I want to make sure that all of you are at that level. All right. So let's keep on going. All right. Now, Jezebel, would you like to read?
Sure. Wait. It's because I can't see. Given the diagram below and that, I see angle.
So it's not an angle, right? Because last time when we had the symbol for an angle, we just had the 2 sides, right? What shape is that?
Triangle.
Triangle. So triangle ABC. And then there's this weird symbol and
DEF.
triangle DEF. Perfect. So when they say triangle ABC, they mean the triangle with points A, B, and C is whatever to triangle DEF. Okay. So what is that whatever? What is that little squiggle? This is a really cool property called similar. Okay. So this little guy means similar. All right. So that means triangle ABC is similar to triangle DEF. What does that mean? Similar means same angles. And by same angles, I mean like each angle in the first triangle is corresponding to the angle on the second triangle. So A is equal to D, B is equal to E, and C is equal to F. Okay, that's what I mean by that. Okay, so same angles in the triangles. All right, again, does not mean that all these angles are the same. Nope, different thing, something else. It's going to be each of the corresponding angles are the same. Okay, so same angles and proportional sides. Okay, what I mean by that? What do I mean by that? Stumbled over my words. So they don't necessarily have to be the same sides, but all the sides need to follow a common ratio. And now I'm about to show what that common ratio is. Okay, so solve for x. Okay, so we are solving for x. Now, we said that angle A is the same as angle D, right? So angle A, whatever it is the same thing as angle D. Cool. We know that angle B is equal to angle E. Okay, so whatever B is the same thing as E. And angle C is equal to angle F. So C and F. Okay. Now, on to the proportional sides. Remember how we were talking about like, where did I talk about it? Oh yeah, right here. With the angle and if you have a really big angle, opposite side is also really big. If you have a small angle, opposite side is small. Right? Give me a thumbs up. Sounds familiar? Makes sense? Cool, cool, cool. All right. Now, we're going to use that. Okay. Angles are associated with their sides. Okay. The opposite side specifically. Okay. So if angle B has to do with side B, well, what does angle A here have to do with? What is it? What length is it associated with? What side? So it's associated with angle D. Yeah, so these are the same angles, right? For sure. Let's look at this triangle specifically though. Okay. Just looking at this triangle, we are ignoring this one for now. What side does angle A have to do with? All right, think of that previous example. We have three options: this side, this side, this side, or this side. What side are we thinking? Let's get some answers in the chat. What are you thinking? So a big angle makes a big side. So that's the side it correlates with, right? A small angle makes a smaller side. So that's the side that angle has to do with. And so on and so forth, okay? So each angle has to do with the opposite side, okay? So if that's the case here, it's also the case here. So each angle has to do with the opposite side, okay? All clear? Put an O in the chat if angle and opposite side, if that makes sense, okay? You know. Awesome, 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 awesome. Okay, now let's get into our ratio, right? Onto these proportional sides we were talking about, okay? This angle, angle A, has to do with 15. And we know that angle A is the same thing as angle D, okay? So somehow 15 has to do with 11.25. Okay? So what does that even mean? Well, I'm just going to write that 15 here, okay? And then also angle C, same thing as angle F. So somehow this 6 has to do with an 8, somehow. And then this b has to do with 10, and b is the same thing as e. So the 10 has to do with x. So we have our 10 here. Okay. So all I did is I wrote the measures of this triangle, and I slapped it onto the corresponding sides. Okay. What do we need to multiply 6 by to get to 8? Actually, we don't need to do that. Overcomplicating it. Okay. Let's make a proportion. All right. We have corresponding sides. Okay. We have 6 for the small triangle, and that corresponds to an 8 in the big triangle. Okay. Have I lost anyone? Does that make sense? That the 6 corresponds to the 8. Okay. Put a C in the chat for corresponds. Michael, that was crazy fast. I like barely finished saying it. Okay. So 6 corresponds to 8. Okay. So that means that 11.25 corresponds to a 15. Okay. And that also means that the x corresponds to a 10. Does that make sense? Put an S if that makes sense. That all these sides correspond to each other. Cool. Okay. We only need one of these. We only need 2 of them. I'm gonna get rid of the more complicated one. I'm gonna get rid of that one. We don't need that one. We just need this. We just need this one relationship. Let's see. Caleb, how do you solve a proportion? Caleb, you there? Mic doesn't work? Okay, no worries. Brandy. Oh, Brady. Sorry, not Brandy.
You multiply the other side by 10 and then multiply x by 8.
Exactly. You just verbally explained cross multiplication. Okay, so you multiply across, it gives you 8x. It's going to give you 6 times 10. All right, so 8x is equal to 60. And x is equal to what? What is x equal to? $7.5. Immaculate, guys. Awesome. And that's our missing angle. Okay. So when you see a bridge, cross it. Ellie, exactly. Okay. So I'm going to zoom out just a second. Give you guys a minute, not a minute, like 10 more seconds to write stuff down. 6, 5, 4, 3, 2, 1. Ding, 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 ding. I'm going to stop sharing my screen. And guys, that was the very last session of the 4. That was the preview of the review preview. That was an introduction to geometry. All right. Now, if you didn't understand anything, that's totally fine. You can ask me. You can stay if you have any more, if you have questions. I'm totally here for that. All right. If you have any questions at all, literally whenever you are in your geometry class and you're confused or something, you can shoot me an email and I will walk you through it. Okay. I took geometry. I kind of maybe sort of know what I'm doing. Ellie dropped my email in the chat. Perfect. You're gonna get a recap from me. You're gonna get a recap from me later on. Okay. And that's it. You guys are free to go. Samuel, see you guys. Elizabeth, bye. Amanda, you were awesome. Okay. Jezebel, bye.